Welcome back. In this lesson, we will be talking about the history and development of natural language processing. Natural language processing started in the early 1940s. The early work of natural language processing started as a machine translation problem. And it was very simplistic in nature. They built the system around a lexicon, and this lexicon was bilingual. They looked up one word from a source language into the meaning of in the other language, and after that they applied word ordering rules. However, the result was disappointing. That is because the system ignored the structural and lexical ambiguity of language. In the 1950s, there has been a conflicting view between linguistics and computer science. Noam Chomsky published his first book in syntactic structures, and he claimed that language is generative in nature. It can be generated by mathematical rules. As a result of this, two trends have emerged. The first trend of natural language processing followed linguistic rules, and they have been hostile to statistical methods. The second trend was completely in contrast with the first one. They believe that natural language processing can be done only by using statistics, and they thought that linguistics is of no use to natural language processing. In the 1960s, the linguistic theory witnessed a lot of development, and computer scientists thought that machine translation was possible. That is because they thought that linguistics is gonna help in solving this problem. However, poor results still continue to emerge, and funding machine translation project was completely stopped. In 1970s, Noam Chomsky introduced the transformational model. As a result, linguistics was dominated by transformational model 2. So, transformation was very abstract. Computer scientists could not follow up with that abstract things. However, other attempts continued to emerge in natural language processing. For example, ELIZA was a system that has been developed in the 1970s, and it replicated the speech of a psychologist with his patient. In 1980s, there has been a reunion between linguistics and computer science. Computer scientists realized that isolated solutions to natural language problems were not effective, and they realized that they need to incorporate other fields of science, including linguistics. As a result, more research was carried out in natural language processing, trying to bridge the gap between linguistics and computer science. In 1990s, the first results have been achieved. So, good progress was achieved, especially in part of speech tagging. And it was achieved with good accuracy, for example, in English. In the 1990s also, electronic text emerged, and this provided a good resource for training and examining natural language programs. Other factors include the availability of computers with fast CPUs and more memory. And the major decisive factor behind the advancement of natural language processing was the internet. In the third millennia, from 2000 onwards, natural language processing and linguistics are going hand in hand. So they realized that linguistics is critical in natural language processing, and statistics and artificial intelligence played major role in this advancement. And we witnessed also faster CPUs and cheaper storage, and there are abundant of resources. We have a corpora which contain trillions of words. Several examples of the success of natural language processing have emerged recently. Take, for example, Amazon Alexa. Now you can chat with this robot, you can ask questions, and it can reply to you. And Sophia is also another advanced example of the success of natural language processing. Sophia is smarter than Alexa because Sophia can do reasoning to some extent. So we have seen brilliant examples of the success of natural language processing. However, 100% accurate natural language processing cannot be achieved even after 20 years. That is because human languages are highly ambiguous, whether in terms of words or the structure. In the next lesson, we will be talking about goals of natural language processing. See you then.